I'll be taking you through the peering scene in Ghana. Basically, we'll look at what we are doing in this country to exchange traffic locally. And this presentation this is basically the agenda for the presentation. We'll give you some history, a little background, the objectives, which are probably the objectives of every IX, achievements so far, equipment that we use, and stuff like that. Now, in 2005, Ghana started off with 2 IXs, and this started at different points in time within the year. Now, the 2 exchange points, one was located at the Kofi Annan Center, that's the GICS, which is the one that's currently most people are connected to, and then the AIX, Accra Internet Exchange, which was located at Vodafone and was established with resources from AFNOG. The AIX, which has most members have migrated to the GICS, was created mainly because of proximity. Most of the ISPs were co-located at Vodafone, and it made sense just to throw a cable down and interconnect there. So that was the brain behind that exchange. Now, both exchanges were are established as non-profit entities. Initial membership, most of them, both had about 4 members initially, and then AIX later had 2 more. And currently, the GICS has about, 16 members. I have 15 there. And the AIX has about 3 members. Objectives of why we went this route, why we wanted to peer. Obviously, keeping local traffic local to enhance the user experience, reduce overall cost for ISPs, encourage local content, meaning that content providers will come and put their stuff at the exchange point and serve their content from there. Create opportunity for content providers and other value-added service providers to make some money, create a business, and most importantly, build technical capacity. Okay. Achievements so far. We've reduced latency between the providers. Initially, providers used to go up through the satellite cable, back down, typically 500 millisecond round trip time, and now it's been reduced to 25 milliseconds because exchange is existing and we're exchanging traffic there, and there's a shorter path to get to each other. We've also reduced the cost of internet transit for ISPs. The price itself hasn't dropped per se, of course, apart from the new cable operator, Main One, who's really brought prices way down. The benefits here are more of bandwidth saving and stuff like that for international accessing international sites out of the country. The Google Cache, which has been installed in the IX, that's the GIX, has improved the user experience for Google sites. And for the Ghanaians here, I'm sure you've heard of you've probably heard the MTN advert, where they play something from YouTube and it's the streaming doesn't break and it just keeps going and going, and other providers networks are they're breaking. The site, the cache, the Google cache is close to you now. The round trip time to get to it, the latency between you and Google is much better, and so you're able to stream without breaks. Obviously, we have better IP coverage for end users, and this for our end users like the banks and so on and so forth who have branches in areas where ISPs do not have coverage. Now they can create their own VPNs from other ISPs to the exchange, and you get reasonable round trip time on the circuits that you put in place for your service. The equipment at the IX, and bear with me, I'm going to go through this very quickly because I think the next session is very informative. So I'm giving most of my time to Dr. Peering. Okay. Now, the equipment at the exchange, basically a switch. What else did we expect? And then a root server. The switch was donated by ISOC, and the root server loaned by one of the peering members, the peer members. This is generally what the gigs looks like. Vodafone comes in via fiber to the gigs. Almost all the other network operators come in over a wireless link, and they all have routers at the exchange point itself. Vodafone is the only one that doesn't have one there. They peer directly from where they are, from their premise. And the Google cache somehow is in the MTN network. So that's why I separated. I mean, I highlighted MTN out of the rest. But this is what the setup, general idea of what the setup looks like. Not rocket science. It's pretty simple. The peers present at the gigs: 16 members, 11 ISPs, 3 telcos, 1 government agency, and a content provider. I've tried to color code them. So the blues are your ISPs, the reds are the telcos, and then the GCNet is your government agency, and then Google Cache is a content provider, or Google is the content provider. Now, obviously, they would like to have more people peering at the exchange so that local traffic is kept local. I don't know if it is. I always say that somebody should legislate that it becomes illegal for a packet destined for your local country to transit outside your country. They should legislate and make it illegal to do that, and then force everybody to peer at this. But then again, these are the kinds of people who would like to see at the exchange. Government, for the e-government project that they've embarked on and putting everything online. Educational and research institutions, very, very crucial. Financial institutions, and then content providers. These are people that would be very welcome at the exchange. Traffic statistics. Peak seen as at last week was about 542 meg, and that's at the root server. This is the amount of traffic that the root server saw. And yeah, I'm just showing a few by week, by month, and you notice that the graph here starts in June. It's not that it's not that the gigs was not in existence then, but it's just a new management station that was built and started graphing in June. These are some of the traffic that the members are pushing and pulling from the gigs. You would notice, and it was interesting to note, that Vodafone seems to be pushing most of the traffic. About 500, it's not very visible here, but it's about 500 meg they are pushing. And the rest are pushing less than 10 meg. I just displayed a few here. Those who are doing more than 4 meg I displayed here. And of course the Google cache itself, where most traffic is going to. Most of the traffic is going to the Google cache itself. Okay, so this is just an idea of what is going on at the exchange in terms of traffic movement. Future projects, obviously, we want to put in a root server to improve the time it takes to resolve names to numbers and browsing experience. Put in more monitoring tools like NetFlow tools to be able to see, finer granularity of kind of traffic that's passing through the exchange. Want to see how much is mail, how much is HTTP and stuff like that. Obviously, I don't recall seeing any ISP in Ghana doing IPv6. If it's there, I haven't yet seen one. Okay, so obviously IPv6 deployment is something to push and ensure that we jump on the bandwagon quickly. I know a lot of organizations, or some organizations I work with, have acquired IPv6 addresses, but we are not able to get anybody to transit through directly unless we do, 4 to 6 stuff, 6 to stuff like that. Another thing is to put a GPS-based NTP server within the exchange so that time synchronization is also kept local. So we don't go and try and synchronize time with servers outside on the internet and stuff like that. We're also looking at Akamai servers. I'm sure we would all agree that Microsoft updates and other updates, such updates, take up a lot of bandwidth. I guess when there's a patch Tuesday, usually is the day that you see a lot of traffic on people's uplinks go up. I mean, everybody is trying to update Microsoft's operating system. Then, of course, you want to have a second exchange point in Ghana. Maybe revive the AIX to give people an alternate place to connect to. So that it's not just Kofi Annan Center. If I cannot throw a link there, I should be able to throw a link somewhere else and still peer with others in the country. I guess that is about it.